Hello learners, welcome back for this session on the functional diagram of 8051 microcontroller. The objectives of this session are to explore the functional block diagram of 8051, to understand the purpose and the scope of the central processing unit, and to explore the subcomponents of the CPU inside this 8051 microcontroller. In the previous session, we had an overview of the block diagram of 8051. Here, now the diagram shows the basic functional blocks or the architecture of 8051 microcontrollers. We know that 8051 follows the MCS 51 family, and in that family there are many series of microcontrollers. 8051 itself has its own family members as 80C51BH, 8051AH and 8051. Each one of them will have minor differences in probably number of pins, the ROM's presence and the number of timers. Our discussion will be more generic and we will explore the major blocks. Thus, as a learner, if you come across any difference in this architecture, kindly interpret. It is due to the versions of family members in the MCS 51 family. In our diagram, the major blocks have been shown. Let us discuss now each block one by one. Let us start our discussion with the oscillators block. 8051 has an on-chip oscillatory circuit as shown in this figure. Through the pins XTAL1 and XTAL2, a quartz crystal oscillator will be connected with the frequency of any value between 1 MHz to 24 MHz. The internal circuitry is made of HMOS devices. Actually, it is high density metal oxide semiconductor devices. The circuitry is suitably connected with VCC and VSS lines of the microcontroller. With the external LC tank circuit, the circuit oscillates and generates a train of pulses. Now let us see the pulse pattern and the instruction time computation. With F as the frequency of the crystal, we get the train of pulses with small t values called the pulses in the microcontroller. Here, one machine cycle includes 12 t states. Thus, the time for any instruction will be Ti is equal to C multiplied by 12 divided by the crystal frequency, where Ti is the time required for the instruction, C is the number of cycles of the instruction. We know that in microcontroller architecture, CPU is the major block. The subcomponents of the CPU are the first part, accumulator. It's a major register with 8-bit length. As all of us know, in similarity with 8085, during arithmetic computations like addition, subtraction, multiplication and division, this register will hold one of the data for ALU. Will also be used when external memory is required. Next item, number 2, is the B register, which is again 8-bit length. This is one of the general purpose registers. In general, it is a scratch pad register. But during multiplication and division, which is a unique operation in 8051 compared to 8085, it is used to hold the data. A point to note here is there are other 32 general purpose registers inside the architecture. They are arranged inside the RAM. In the following sessions, you will be getting it very much clarified. The third component is temporary register 1 and temporary register 2. These are temporary registers used to hold the input data to be given for the arithmetic and logic unit. The fourth component, if you look at, program status word register called PSW. This is a bitwise function register provided for storing the status of results, like a flag register. There is one more such status register called power control register, PCON, located inside RAM. Here CY is the carry flag, which is the overflow for the whole 8-bit, which is the 9th bit overflow. Then auxiliary carry flag D3 to D4 overflow. There's another flag called OV, that's an overflow flag also, which is meant for some change in signed 2's complement operations. P refers to the parity flag, normally odd parity is followed. Other new flags here is, one is called FO, which is used for program event status by the users. Then we have RS1, RS0 pins inside PSW, where 00 combination of these two bits refers register bank 0, 01 for register bank 1, 10 for register bank 2 and 11 for register bank 3. The fifth block of consideration in our architecture is ALU. This unit consists of adders, comparators and multipliers to support the arithmetic computations. Also, combinational circuits are available to perform the logical operations. Their computation results directly impact the status of the PSW register. The next major block of interest is instruction register, available to receive the instruction opcode, and timing and control block. Here, using the oscillator input, relevant control signals like program store enable PSEN, ALE address latch enable, external access EA and reset signal RST are generated. Finally, let us consider blocks for program memory access, namely the program counter PC, then PC incrementer, buffer and the stack pointer SP. The new block of interest, unlike our 8085 microprocessor, is DPTR, which is called data pointer in 8051. 8051 uses this access external memory by storing a 16-bit address in DPTR. Next, other than the sub-blocks considered, there are some registers available inside the CPU called special function registers located inside the RAM IC. Interrupt control is a part of the CPU, but for convenience, it's given as a separate block. Timing and control unit has a close association with oscillator circuit. So these are all the additional parts of discussion. Thus, we have completed our discussion on the CPU of 8051. To summarize, we discussed the functional block diagram of 8051. We had a clear insight into the sub-blocks of the CPU. Thank you, learners. See you in the next session.